we are going to talk about the most important aspect of C++ language today, okay? So this is something that if you don't know it, then you might as well not write any programs in C language. Why is it only at the end of the semester? Because you need to know how the language works before you actually be able to use this part. But as soon as you learn it, then it opens up a huge gateway for you to do amazing stuff. We'll go through it, and you'll see what I mean. So to start up with this, I'm going to write some sample classes over here. Not write, I'm going to copy because I don't want to waste your time. Now you're at the stage that you can simply say what it is. So I always bring up a container. You know that, right? So I have a class called container. It has a data, and that data is what it contains. It has a constructor that sets the data to a value. It has a binary operator plus that receives a container at left and a container at right and returns the sum of the two. It has a display that shows the container data with a CN in front of it, so we know it's a container. And it overloads the cout, the insertion operator, so it can work with OString. Are we okay with this? Like, we've done this like 50,000 times already. Are we okay? Are we okay, everyone? Any questions about this? And then I'm going to create another similar thing over here. Let's call that a mark. So mark has a data, and it has it's exactly like a container, but the difference is that when you add the data of two marks, so what you do over here is, did I do something? You could see a screen, right? Okay, so let me pause. Yes. So the mark that we have over here is exactly like container, but operator plus for mark is kind of different because a mark's sum cannot go more than 100. So I am getting the M data of this object and M data of the right-hand operator, see if it's greater than 100. I'm going to correct it to 100. If it's not greater than 100, then I'm going to actually pass the sum. So mark plus is a little different, the logic behind it, but it's mark plus, correct? So going back to what we have done on the screen and just quickly copy what we had in there. So now if I come back in main, and in main of mine, I have stuff like this, return 0. Okay, so as you see in here, I have double, I have integer exactly the same way, and I have mark that has a value, two values, and then I have a container that has two values. Are we okay with this? All right, and this 30, I'm going to make it 80 just to make sure that it actually shows what's happening in here. And then I'm going to write my sum function. So again, I have a sum function, and the sum function of mine for integer and double, I'm going to have int sum, int a and int b, as we put it on the whiteboard, return a plus b. And then I have the double one, double sum, double a, and double b, and I'm going to write the function like that, so return a plus b again. Now, the amazing part with this is that now I can do the exact same thing for mark and container. So instead of creating some for like having those things, I can have something like container, sum, container a, container b, and in here I can say return a plus b, because plus is overloaded for container, correct? Are we okay with that? And I can do the exact same thing in here for the mark. right? Are we okay with this? Now, in my code, I can call those things one by one, and everything should work properly because the proper overload for it is called, right? So if I run this beautiful program of mine, well, we'll see that 3 years later, after it's executed, I will put this one over here, and I'll put this one over here, and we'll go like this. So I have the container and everything created. This goes into the integer, returning the thing and print it. This goes into the double, returning and print it. This goes into the mark one and does it and prints it, correct? And this one goes to this container one and does what it's supposed to do and return it. Are we okay with this? Any problem with this? No problem, right? Now, what if I have 50 other things that I want to do the exact same thing with it? 50 other types. Now, the sum that I'm writing over here, please appreciate that is not sum that you really do. In real life, when you have the logic that is identical, so what's common between these 4 overload is not that they are only overloaded. The logic within are the same. So they are essentially doing the same thing, but for this different object. And now let's say I have 50 other types that I want to do it. So I have 50 times I have to do this overload, right? So what do? I'm going to tell one of the IPC students that is day 1 coming in, and I'm going to ask them, can you do me a favor, please? I'm going to give you a blueprint of a function, okay? So there is some type, and it's a sum, and there is another type, A, and another A, and another type, B, and then in here it's return A plus B. Look at that blueprint and go through my code. When you see sum is called, see what type it's using, rewrite that using this type. So that person, my 9-year-old, can do that. Just comes over here, sum x and y is double. So I'm going to say double sum, double A, double B, correct? Then it comes over here. Oh, there is another sum over here with I and j. I and j are integers. So integer sum, integer A, integer B, correct? And it keeps going like that and can rewrite this thing for me. So if I don't have these two, then what's going to happen? Then no function for container and mark will be written, correct? Only functions will be written for me that I'm actually calling. Otherwise, there is no code for it. The only thing is that I have to comment this somehow so it doesn't get compiled, and I'll tell to my daughter to, hey, sit over here, and anytime you see something like that, please just create the function for me. Exactly like that, just change the types. Are we okay with that? We can ask the compiler to do just that. If I just say over here, and this type could be anything. I can call it T, I can call it type, I can call it hee-haw, I can call it anything. It's a placeholder. All I need to do over here is to say template, because it's literally a template. Have you seen templates, right? Those template rulers that you template. Template, and you say over here, the type name in the template. In here, it's type. You could name, like I could literally call this one T instead. I could say T, 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 T. And many people actually do that, especially those who are lazy, don't want to type too much, which is 90% of us will do that. But it doesn't matter. You can have it. But over here, because we are teaching it, I want to tell you it's type. When you give this to compiler, you are giving the logic to the compiler. So the compiler comes through and checks. Oh, there is a sum. First, it checks to see if there is an overload somewhere for it. There is a function for it. If there is no overload, then it sees if there is a template to write that. Oh, there is a template. And the types match exactly this. So what happens, it generates that for you at compile time. And if you have all 4 of them, 4 functions will be created. If you have 2, 2. So if your source code only has 1 sum call, your executable will be smaller, because only 1 function will be written by compiler for you. But if you have 90 different calls for 90 different types, then 90 functions will be written, and your executable is going to grow bigger. Depending on what you actually create, the compiler will write the code for you. Do we understand this? And it's exactly the same thing. If I run it, you will see that it works the exact same way. Absolutely no difference. See? Oh, of course, I did 2 of them. Now, if I make it 4, oh, and it runs like that. So it doesn't matter. You have 2, you have 2, you have 4. It's going to generate it for you. So whenever you have a function that you want to write, and your function has the same logic, but it's only different with types, you can just convert it to a template. And don't worry about it. Any new type that is coming in, you can, the compiler will write it for you. But a template must come with heavy documentation. Why? Looking at this function and generalizing the type that you see over here, what features the type should support so this thing can work? Tell me. When you're passing a type by value, what will be called? Copy constructor. So so you have to document this. You have to mention in here. So what you do again, you come over here 1, 2, 3, and then you write over here returns the sum, and in here for the parameter it's got to say must support copy construction, copying, right? What is the next thing that you see should be over here, should be covered for the 2 types A and B? You answered once. Someone else. What else in here should be supported so this works for the type object? No. It's just 2 lines. Over here, it was copy construction. What do you see in here? Operator plus, right? Operator plus. So operator plus should be supported by type for this thing to work. So then in here, I'm going to say and operator plus. You shouldn't have helped me with that. That's how I pay back. All right. So you understand what I'm going with. So anytime, and then in here, obviously, you're gonna write over here a type object, something like that, and returns the sum of the 2. The sum of 2 using operator plus, right? So now so if somebody wants to use this function, they know that their class need to have those things. Because my class did not have any classes with any resources outside of its scope, copy construction was not needed. Because of that, it works for it perfectly. The only thing that it was needed over there was operator plus, that I implemented it already. Do I make sense? Do I make sense? Right? So remember a long time ago, in a galaxy far, far away, I talked about how the compiler works. Remember that? Anyone? Remember when I said how compiler works? Let's use this one. This is good. Remember this? And I said when you actually compile something, each module is compiled separately without knowing that the other modules exist. So the module 1 gets compiled by itself and the object for it is created. Then module 2 is compiled separately and it's created, and module 3 is compiled and module 4 is compiled separately. So when module 1 is created, existence of module 2 is not necessary. Even if, for example, in here, module 3 is using module 2, correct? Because it's including the header file over here. So how does it compile? Because the prototypes of the functions exist over here in the header file of module 2, it just promises that the functions you are calling will exist somewhere else. You do the function call, when I link, they're going to be there, right? Okay. The problem with templates is that when you're actually dealing with templates, ladies and gentlemen, if you just put the prototype in a header file, compiler has only access to the header file, to the prototype, not the logic, correct? So it won't be able to generate its code. Compiler needs to know how a template works to write the code for you. If you don't provide the body of the, because it is not, if you make it a module and try to use some in another file, then that file is being compiled only with the prototype of the template available. And the code of the template will be in a CPP file, another CPP file. That's going to get compiled later. Because of that, the compiler doesn't know how to create the function. And because of that, there is one catch with templates, that is, template modules, they don't have a CPP file. Everything must be in the header file. The source, everything that you have in a template, it must exist in the header file. We okay with this? Are we okay with this? When you have a module and you write the prototype of a function and you're compiling the code, and you're compiling the code, where is the body of that function? In another file, not in this file, right? And when it's getting compiled, your code is getting compiled separately, and when you're actually separating, you're separately compiling your code, the compiler looks at the prototype and says, okay, so this is how the function is called. And that's all it needs to know, how to call the function. So in the source code, it calls the function, correct? Then after everything is done and it's over and the function is compiled and ran and everything is fine, so when everything is done in here and it's compiled and the object code is created, compiler is satisfied and tells you there is no error. And then when everything is done, the linker is called, brings the source code and the function call together, therefore the function can be called, correct? But if you have a template in here and the source code of template exists over here, because in this function the template is not called, the compiler will not generate its code. Because templates are only created if they are called. The place your template is called, there is no source code. So compiler doesn't know how to create it. The place that you have the code, the function is not called. So the compiler won't generate the code. Because of that, any module of templates should not have a CPP file, and you put everything, function, code, all the thing that you have in a header file. If you don't understand it with this explanation, just remember, modules, template modules, they don't have a CPP file. It's just a header file. That's all. I'll demonstrate. So a and remember, this is just a type. So anything you want to do, you want to pass a pointer, you want to pass what should we call it? You want to pass a reference. Anything you want to do, you can actually do it. There is absolutely no problem. So in here, if I wanted the reference of something being passed, no problem. You write const type reference A. So when it's an integer, it becomes constant integer reference. When it's mark, it becomes constant mark reference. When it's container, it becomes constant container reference. Yes? Oh. Okay. Auto is to create a variable. Here is to create logic. With auto, you create one variable. With template, you create a logic. So what happens, auto is this, for example. I'll explain it. So let me just save this for now. So the answer, your question is not relative to this one. So I'm going to save this, then I'm going to answer his question. So we are not teaching templates now. Okay, people? It has nothing to do with templates. I'm just going to do this. Oh, where's my mark thingy that I had? So this is my mark, correct? And say this actually returns an integer, not a mark. Are we okay with this? But you don't know that because you didn't look at the source code. You just know that mark, what mark does, the plus returns the sum of the two marks, but you don't know what it is that is coming out. You didn't look at the source code. You don't have access to the prototype of the function. And you just want to find the sum of the two marks and just print them out. Right? So how do you create a variable for it? You don't know. So you say auto sum is equal to m plus n. So what happens is that the compiler says, I'll check for you what is it going to return, and I'm going to create that sum for you. So if the plus is returning a mark, sum will be a mark. So you don't need to go and check, and you just print the sum. If it's mark, mark is printed. If it's sum, sum is printed. So this auto of yours, writing it like this, if I do C out in here, sum so if I do this in here, as you see, it's going to print 80, correct? But if that thing was not an integer and was a mark in here, and it was returning a mark instead of, I didn't need to change my source code now. Do I? No, I can just do it like this, and still works, but instead of 80, it's going to say MK. So in here, you're saying, give me the variable that is the return type of that one. In here, you could just go check the prototype. But later in OOP345, because of polymorphism, you really don't know which version of the function is called. And because of polymorph, you don't know which object is created. So what its return is really not known. And it happens as what we call it dynamic dispatch. It means it depends on the way the thing is executed. So I really don't know what the type is that is coming in. If that's the case, I do auto. Does that make sense? So it has nothing to do with template. There are two different things. Template is that I have a logic that I want to write, and I want it to work for all types. So let me make it a template. Auto means I am getting an object that I don't know what it is. Let me create one. That's what it is. And this comes much more sense when you come to lambda expressions and standard template library and all those things. When you get to that thing, you see you cannot live without this. And the type that sum has, you will see in OOP345, the type that sum has is 95 characters long, because the type is this dot, that dot, that dot, that. Like it's like a hierarchy of 50 objects goes to a type, and you have to write them all up. You just write an O2 and you're done. Got it? O2 revisited. We didn't revisit it. Actually, we talked about it for the first time, but you asked and I had to explain, right? So let's do this now. I'm gonna IPC 144. You recall that we had IPC 144. You recall that we had some algorithm parts. Remember that? Like showing what different type of sorts are and things like that. They were explaining those things. You don't remember at the end of the semester? Algorithms, no? But okay. Anyway, so one of those, like sorting, I'll give you a very simple one. I'll do, what do I do? I'm going to do the, so let's do this. I want to show you something. So first, I'm going to create a class for you. The class is called name. So it actually holds someone's name. It has a constructor. It has dynamic memory allocation. So it dynamically holds a name. It has copy constructor. It has, so rule of 3 are implemented for it. So it essentially holds the name dynamically. It deletes the name at the end. And if you add two names, it's going to concatenate the two names together. And so it does all that. It has greater than sign, so it string compares the two names and tells you which one comes at first in dictionary. So it has greater than, less than. And it has a display that shows it. And it has a cout that prints it out. So I can create a name and I can print it. Are we okay with this? Very simple class. We've done it so many times. Okay? So having that name, let's do something like this. So I'm going to create a main over here. And this main of mine, I'm going to have arrays like this. I have series of integers, series of doubles, series of names, 8 of them, right? And I want to sort them all. How do you create a template? What you do is to first you write your logic for the simple one, something like an integer or a double. And then you look at it. So let's do it. So we're going to write a bubble sort for the, say, the double one. Okay? So I want to write a bubble sort for double. So what I will do right this, it's going to be like this. So void sort. If you don't remember this, go check the last section of your IPC 144, last chapter called algorithms. It's all there. So how do we sort an array? So I'm going to say over here double pointer array. So that's my array that I want to sort. Obviously, it has a size. That's the number of things that I am going to sort. I need a couple of indexes to compare the elements one by one as I go through it. I start from the beginning of the array, and I'll go right up to the one to last. And then within the thing, I'm going to compare the two neighboring. So how the bubble sorted working like this. So I do this. I compare these two. And if it's not the same order that I want, I switch them. And I go to next, go to next. And I keep doing that. And I come back and do it, come back and do it, come back and do it, come back and do it until everything is sorted. So I compare neighboring things. So for example, if I want it to be descending, I will say, or ascending, let's say. I want it to be ascending. It means smaller first. 1, 5, this is good order. I'm not going to change it. I'm going to come over here. 4, 5, I will change it. So I'll put the 4 over here, the 5 over here. I'm going to come over here. 5 and 3, I'll switch it. So it's going to be, 3 comes over here, 5 comes over here. 5 and 78, I let it be. Then 78 and 9, switch it. 78 and 4, switch it. 78 and 6, switch it. 78 and 4, switch. I go like that. The biggest one goes to the end. Then I come to the beginning. Because the last one is always the biggest one, the next time I'm going to go one less. Because the biggest one always is pushed to the back, they call it bubble sort, because it's like bubbles that go up. Okay, they call it bubble sort. So it pushes. So that's what I'm going to do. So the second time I'm going to write. So this for loop goes from the first one to one to last, because when you are here, this one and next one is the last one you're testing, right? So that's that one. For the next one, I'm going to go for j set to 0, j less than size minus I minus 1 and I plus, j plus plus. Okay, I always go right up to the, because when it's 1, I only need to test the first one. Then it goes here. I only need to go up to that one. And it keeps going. Then I'm going to go to the end. Then in here, I'm going to say if I want it to be ascending, so descending is not what I want. So I'm going to say if the current array one is greater than array, sorry, not I, it's j. So if I'm saying if the current one is greater than the other one, switch it, right? So how do I switch it? I'll write a function for it. I'm going to write over here swap or switch array j and array j plus 1. And how do I write that function? That's the easiest thing you can do. So in here, I'm going to say swap double pointer A, double pointer B, and I'm going to create a temporary one. So in here, this is void. I'm going to say double temp, or T, is equal to target of A. Now target of A is target of B. Then target of B is T. Done. Obviously, I'm going to put a prototype at the top so my sort can use it. Okay, so now what happens over here is that I go through the array and I sort it. Let's see if it actually sorts it. Okay, so I'm just going to do the double one because I don't have anything for the others. So what I'm going to do in here is this. I'm going to say, what am I going to say? I'm going to say sort D and 10, right? Then I'm going to print all of them. How do I print all of the doubles? I'm going to say prn array double pointer. This is a constant, actually. Constant double pointer, double pointer array and integer size. And I'll go through them one by one. Obviously, it's a void. And I'm going to say start from the beginning. I set to 0, I less than size, and I plus plus. And I'm going to say print the array, array I. And if I is not equal size minus 1, print a comma to make it comma separated. Right? And actually, it's a good idea to, you know how I do it. So OStream reference OSTR. And in here, I'm going to receive the OStream reference. And in here, instead of cout, I'm going to put OSTR. And I'm going to return the OSTR. So I just, and at the end, return OSTR. So in here, I can say prn array. And I'll put D10. And I'm going to go to new line after. And go to new line after. Obviously, I will default the OSTR to be cout. Okay? And this one is going to be std2. And this one is going to be std2. Okay? So when I run the program, hopefully, if everything compiles and it works and I don't have an error, you will see that the double array is actually sorted. Where did it go? Okay, one more time. The double array is sorted in an ascending order. Are we okay with this? Everybody's okay with that? All right. So how do I convert all these things to a template so I don't have to rewrite it for the integer and the name? First, I have to put them all in a header file and call it sort. First, print array has nothing. Let's first do the print array. Print array has nothing to do with sorting, so I'm going to make it a template right here. How do I do a template? I'm going to write over here template, type name T, and then think, okay, what needs to be generalized in here to do the sort for me? The type of the array, so that double should be T. Okay. What else needs to change in here? Do I need to change this integer? No, that's number. Number of cars, number of names, number of integers, number of doubles. Number is number. It's an integer. Do I need to change OStream? No, it's to print. I don't change that. So I'm done. That's it. So how do I document it? I need to know what needs to actually work for this. So I'll go on to 3. Summary, I'm going to say prints an array in comma separated format. Okay? And the parameter over here is going to be the array type. Right? Array type must do what? What do you see? So when it's telling you, when you want to check to see what is important to be done, take a look at the type. Type is in front of a variable, correct? Look at that variable inside your code and see what is it used for. I have array I, so that's an element of type T, correct? T can be printed on OSTR. That's the only thing it needs to do. So in here, I have to say, array type must be insertable into OStream. Other than that, I have nothing else, right? So now my print array is a template. Let's see if it still works. And it does. Because when print array is called, it says print array D, and because D is a double pointer, it literally is a match to this one. So T over here will be whatever it is. Are we okay with this? Right? Do I need to put this in sort.h? No, because printing an array has nothing to do with sorting. So I'm just going to, now I'm going to move the sorting stuff over there. So taking the sorting stuff, these are the ones that I have. I'm going to copy it and then comment it. Now in here, I'm going to create a header file. Was it this class that it didn't compile and it was because of the header file? Something? Okay, so once what I did, I want to tell you, if that mistake happens to you, don't do it. You know what's wrong with it. Once I wanted to create a header file, by mistake, I created CPP file. And I said, I'm not going to recreate it. I'm just going to change that. So I came over here and simply converted this CPP to .h. If you do that, it doesn't work because the IDE thinks it's still a source code, tries to compile it. So don't do that. If you misspelled it, delete it and recreate a header file. If you do that, you're going to get a compiler. Nasty one. It took me half an hour to find out what went wrong. So in here, I'm going to say add new item. So right from the beginning, you have to say .h. Okay? And in here, I'm going to have, as usual, if not define stds sort h and define, and I'm going to put z copy, and okay. So this is the thing that I have. A template statement only affects the incoming scope, and everything must be converted, even the prototypes. So this prototype is going to be a prototype of a swap that is supposed to be changed to a template. So in here, I have to say template type name T, and in here I have to say T and T. Okay, that's it. That's one thing I need to do. Now I come down here and I'm going to bring the exact, so you can write over here now, template type name type. So to swap this thing, this obviously has to be type, and this has to be type 2. Do I need to change this too? Yes, of course, because it's a temporary value for that, so that's going to be type. Now I have to comment this. You can do the comment up here for that one, or it's better to do it for the the prototype. But it's when you're doing something like this, it's better to bring this up and don't have it up there. This will work perfectly, but I don't want to confuse you, so I'm going to take these things up. Okay, so we don't need a prototype for it. But if you need a prototype, that's how it's done. So I'm going to comment it, so you know if prototype was needed, that's what we're going to do. So now if I want to mention over here, what do we need? So what do we need over here, people? So type pointer A, type pointer P, nothing special over there. It's passed by address, nothing will be invoked. Type T is equal to target of A. First of all, we know it's a constructor. Assignment at the moment of creation is what? One argument constructor. What is the type of the argument? It's type, correct? So you are creating a type out of another type, which means copy construction. Then you're assigning a type to another type, correct? That's copy assignment. And your type will die at the end because you created the type inside the swap, correct? That's rule of 3. So you have to mention over here, type must rule of 3 compatible. Either compatible, so if it has dynamic stuff, it has to have copy constructor, copy assignment, and destructor. And if it doesn't have dynamic stuff, it is, if all the data is contained, then it is rule of 3 compatible anyway. So that's what it needs to do. So over here it's going to be type object to be swapped. And object to be swapped. Okay? Address of. Okay, and summary swaps the contents of 2 objects. Okay? Now, I'm not going to change anything. I'm not going to template the sort yet. I'm going to test the first one, see if it works. I'm going to run it to see if it actually sorts it. Build errors, let's see, what is it? What did I do wrong? Sort identifier not found. Oh, because I didn't include sort.h in here. Include sort.h, I need to do that. I run it, and it works. So the swap is working, right? Now the next thing I want to do over here to make the sort work. So again, template, type name. It's very bad practice to have different type names as you go. Either you choose one. I'm using different one just to show you it doesn't have to be type. It can be anything. But if you stick with type, use type everywhere. It's easy. Okay? So the placeholder you are holding over here that I call it type, you can call it anything. I'm going to put T over here just to show you that it's different. Yes? Oh, yes. Each template only affects the next scope. It ends over here. And now I have to create another one for this one. And that's any scope. Okay? You will see soon. Okay, so that's that. So now over here, obviously I need to be, it's need to be a T array. And what else I need to change in here? I and J are indexes for the loop. Nothing. That's it. The only thing I have to mention that, so this is an array, so I have an array. So greater than operator should work with this sort between the 2 objects. That's the only thing I need to do. Nothing else is needed. Right? So again, in here, you're going to add a comment over here saying sorts an array of objects. And in here, I would say operator must work with T. Okay? In here is array to be sorted, and that's size of the array. Right? Okay? So let's see if it works. I compile and run it again. And it's working perfectly. Now it's time to test and see if it works for everything now. Because my name in here has the rule of 3, and because my name works with operator greater than sign, it has lots of other things. I don't care. These are the important ones. My name should be sortable by this. So what I will do in here, I'm going to go into my main, and I'm going to actually sort them all and see if it works. So I'm going to come right down here, write the sort for all of them, because now it's a template. It's supposed to work for everything. And when we look at it, we see, yes, it is working for everything. Right? That's the beauty of templates. You write the logic once, you apply it to everything. That, ladies and gentlemen, is true polymorphism, which brings us to what we need to talk about here. Actually, I said that this is the last lecture. I think I lied because of all the things that we had. We lost around half an hour. So I'm going to have like 20 minutes of things the next time you're coming in to talk about class templates. Class templates are just touched here, but I'll explain to you later. So not only functions can be templates, you can actually make a class template. And that's where everything becomes amazing. Okay? I mentioned it in the other class. Remember old times, the slogan for the Apple cell phones? They would say, you want to do this? There is an app for that. You want to do that? There's an app for that. Like you want to do accounting? There's an app for that. You want to go parachuting? There's an app for that, right? There's an app for everything. In C++, you want to do anything? There's a template for it in standard template library. You want to do search through an array? There is a template for that. You want to do a parallel execution of an algorithm on some big data so it runs faster? There's a template for that. So that's why I said without knowing templates in C++, you're not going anywhere. The whole point of C++, it's the power of C++ is its templates, that you literally can write quick and efficient programs without actually implementing. You want to do a binary search? There is a template for that. You don't need to actually go study data structures. You need to know what binary search is, so you kind of know it. But to implement it from scratch on the things, you don't need to. There is a template for it. Anything you can think of, algorithms, it's hard to explain. In 345 you'll know, but there is a template for it, and I'll explain when I get to classes. I'll explain to you how it works, and I'll explain another thing today before we leave. So that's the sort thingy. But I wanted to talk about this. Now that we know templates, I can give you an overview of polymorphism in C++ to see exactly, when we say polymorphism, how the polymorphism is actually implemented in C++. The yellow one, this left one, but we call it ad hoc, I call it fake polymorphism. It's a pretend. It's not really polymorphism. They polish it to show it that way. Coercion is casting. So the good old casting that you did in C. In C language, you write plus between any two variables. Integers, doubles, double and double, double and an integer. It works. Is plus a polymorphic thing in C? No, it's not. It's casting. Temporarily, it's changing the type of an object to something so the plus works. So casting is not really a polymorphic thing. But plus works for everything. You don't need to change the type, so it's the same action done in different ways. Therefore, polymorphism. Next thing we learned, the very first thing we learned in OOP244, overloading. When you do overloading, is it really polymorphic? When you, for example, the sum functions that I have written, the first one was sum int int, correct? The other one was sum double double, sum mark mark, sum container container. When compiler compiles these things, it actually attaches the types to the name. So your sum is not really sum behind the scene. Your sum is sum int int. So it's not that the sum is happening in a different way. There are 4 different functions. And each function has its own name because it attaches the types to it. Therefore, it's not the same function. It's completely different ones. Therefore, not polymorphism. It is polymorphism, but we call it ad hoc polymorphism. I call it fake polymorphism. It looks like polymorphism, but it's behind the scene, it really is not. But when we come to universal polymorphism, real polymorphism, that's where everything is actually identical. The function you are calling has the exact same signature. Everything is the same thing, but the proper one is selected based on the hierarchy. Virtuals. Every single virtual call you made is an inclusion polymorphism, which essentially it detects which version of this function should be called based on the type of the hierarchy you have. It is identical function. It is the exact same signature, but it happens differently. That's real polymorphism. And the last one we just learned today, templates. You don't even have a function. You just write the logic. Compiler builds it for you based on the types off scratch. That's parametric polymorphism. That's real polymorphism. You just mention what needs to be done, compiler does it for you. You don't even write the code for it. You just write the logic for one thing, and then it will generate the code for you as it gets compiled. And that's the fourth one. It takes 3 seconds to go through this lecture because now we know everything. Okay? So, templates, virtuals, overloading is overloading, casting. Got it? That's all different types of polymorphism we have in C++. Are we okay? All right. Having said that, how much time do we have? 11:16. You know what? I'm going to leave it as right at this point, so the next time we are coming in, remind me to continue with classes. Okay? So this is it for today, because the other one, if I open it, it's going to be a can of worms. We'll have to go for like 40 minutes. I don't want that to happen. So the next day you are coming in, or maybe we're going to do it in a lab that you're coming, the next lab that you're coming. We're going to do that. Your milestone 3 is due in tomorrow, right? Yeah. And I'll put 4 and 5 up on Wednesday. So, yes. I don't know. Check -2. Saturday? Saturday. Okay. Do -2 on that. I'll put workshop 10 up too, and it's about templates. Very simple workshop. Okay? Probably you got it writing one function and that's it. Yes? Have you started code reviews yet? Pardon me? No. I'm going to, in last 3 weeks, we're going to do everything because I want to post everything to be done. Project, workshops, all the things to be up, and then we'll start. Okay? Before you submit your last milestone so you can modify your code and make it better.